Welcome back again to Advanced Functions, MHF4U1. This is the last chapter of the section called A Trigonometric Identities Equation. In this lesson number 6, we are going to solve a quadratic trigonometric equations, or various different types of equations. Let's start with question number 1. Solve for x. So we're given a domain where the domain is in between 0 and 2 pi. Tangent squared x is equal to 1. So first, what I'm going to do is I'm going to square root both sides. So square root and square root. Then you will get tangent x is equal to plus or minus 1. So then, for the positive side, tangent x is equal to 1, and for the negative side, tangent x is equal to negative 1. Now keep in mind that, so if it's x, so we're going to move tangent to the other side, so it becomes tangent inverse 1, and x is equal to 45 degrees, which is pi over 4. So therefore, we have to look at the cast rule, C-A-S-T. Now, which quadrant would my tangent be positive answer? Because it's positive 1 here. So tangent is positive in quadrant 1 and quadrant 3. So therefore, so quadrant 1, we already know that we already found the related acute. So that will be in quadrant 1. X is equal to pi over 4. Now to find the answer in quadrant 3, x is equal to pi plus pi over 4, which is 5 pi over 4. So we have two answers when the tangent x is equal to 1. Now what about the negative one? Again, so x is equal to inverse of the tangent 1, negative 1, x is equal to, so in this case you still get pi over 4. So that is my related acute, which is less than 90 degrees. After you find the angle, let's do the cast, C-A-S-T. Now, which quadrant would my tangent going to give me a negative ratio? So negative is going to be in quadrant 2, right? Only sign can be positive, and quadrant 4. So let's start with quadrant 4. So it's going to be, the formula is 2 pi minus theta, which is pi over 4, and it's going to be 2 times 4 is 8. 8 minus 1 pi, so it's 7 pi over 4. And then for quadrant 2, it's going to be pi minus theta, which is pi over 4. And 4 minus 1, it's going to be 3 pi over 4. So therefore, so when tangent x is equal to negative 1, I have two answers where x is equal to 3 pi over 4 or x is equal to 7 pi over 4. Now so there are only 4 answers if the domain is between 0 and 2 pi. Now what if I were to say there is no domain? So that means there's going to be lots of answers. And keep in mind, for tangent, the period, the cycle happens every pi, not 2 pi. So therefore, x1, the first one, it's going to be pi over 4 plus pi k, meaning k could be any integer represented with z. And x2 is going to be 5 pi over 4 plus pi k. And then again, k could be any integer. And then you're going to do same thing. The third angle can be 3 pi over 4 plus pi k. Okay. And again, k can be any integer, so belonging to. And the last angle is going to be 7 pi over 4 plus pi k. And then again, k could be k belonging to any integer. Okay. But you will notice, so there are 4 possibilities. But you will notice that because tangent, the graph looks like this, right? It's a repeating pattern. So this is pretty much exactly the same as this one. It's same. And 3 pi over 4 is exactly the same angle as 7 pi over 4. So it's same. So therefore, you could just say just 2 types of answer. So x could be pi over 4, or it could be 3 pi over 4, because the other 2 angles are representing exactly the same position when it's in cycle. Question number 2. Again, we're solving in terms of a quadratic equation. So we have sine squared 2x is equal to negative sine 2x. So we have like a double angle formula. So what I'm going to do is I'm going to move everything to one side. So let's move this to the other side. So sine squared 2x plus sine 2x is equal to 0. And you notice that we have a common factor of sine 2x. So I'm going to factor sine 2x is equal to sine 2x plus 1 equals 0. Now, so I'm going to let each factor equal to 0. So for this one, sine 2x is equal to 0. And then you will notice that the sine is 0 when it's on the x-axis, because it's going to be 1, 0 and negative 1, 0. Right? It's the unit circle where the y value is 0. So we could say that 2x is equal to 0 and 2x is equal to pi, because this is 0 degrees or 0 and this is pi in radians. So therefore x is equal to 0 and x is equal to pi over 2. So these are the 2 angles that are possible for this factor. Now what about this one? So we have to say sine 2x is equal to negative 1. I'm bringing it to the other side because this is equal to 0. And then we could say 2x is equal to sine inverse negative 1. And then 2x, when you punch it in the calculator, it's going to give you 3 pi over 2. Therefore, what I'm going to do is I'm going to divide everything by 2. So x is equal to 3 pi over 4. And then this will be the third answer. Okay. So the reason why there's no 2 angles for this one, because 3 pi over 2, it's located over here on the y-axis. So because it's only within the 4 quadrant, there's no other angle other than 3 pi over 2, okay, which is 270 degrees. Next, we have 2 sine squared x plus sine x minus 1. Okay, so you'll notice that, do you see like a pattern of the form? It looks like a quadratic formula in terms of a trinomial. So you could say let A is equal to sine x. So what this actually will look like, if I simplify, it's going to be 2a squared plus a minus 1 equals 0. And then you could do product and sum. So something times something equals -2. Something plus something equals 1. So it will be 2 and 1, and it's going to be -1. So 2, -1. So let's factor. Using decomposition, 2a squared plus 2a minus a minus 1 equals 0. Okay, 1 equal sign. And I'm going to common factor the first two, 2a. So it's a plus 1. And then I'm going to factor negative, so it's a plus 1 equals 0. Therefore, a plus 1, 2a minus 1 is equal to 0. So what we can do now is we can replace a with sine x, going back to the original question. So sine x plus 1 and 2 sine x minus 1 equals 0. So what we're going to do, we're going to let each bracket equal 0. So the first bracket is sine x plus 1 equals 0. So sine x is equal to -1. X is equal to sine inverse -1. So x is equal to pi over 6. Oh no, so it's going to be 3 pi over 2. Okay, so again, 3 pi over 2 is on the axis, which is over here, 270 degrees. So there's only one answer. Okay. Now, what about the next one? We have sine x, 2 sine x minus 1 equals 0. So I'm going to move -1 to the other side. So 2 sine x equals 1. Sine x is equal to 1 over 2. And you're going to do the inverse. X is equal to sine inverse 1 over 2. So x is equal to pi over 6. Now you will notice that pi over 6 is 30 degrees, which is located here. Okay, so this is my related acute. Now, so we have to ask ourselves, where would sine be positive ratio? Because it's sine x is equal to 1 over 2. So it's going to be in quadrant 1 and quadrant 2 using cast rule. So we know the quadrant 1 is going to be same as my related acute. So it's going to be pi over 6. And for my quadrant 2, so you got to use the formula. X is equal to pi minus theta, which is pi over 6, my related acute. And that will give me 5 pi over 6. So we have 3 possibilities for this formula. 3 pi over 2, or pi over 6, sorry, this is pi over 6, or 5 pi over 6. So when you see an equation and you're solving it, if you could factor, that would be awesome. Okay, next question. So we have -10 cos squared x plus 9 equals to 3 sine x. Again, when you're solving for something, the equation should equal to 0. So I'm going to move everything to one side. So let's move this. So I want this to move to this side so I can make it positive. So it's going to be 10 cos squared x plus 3 sine x plus, minus 9 is equal to 0. Okay. Now, unfortunately, we have two different trig ratio. We have cosine and sine. So what I'm going to do is I'm going to change cosine into sine. So using a Pythagorean identity, we know that cosine is equal to negative sine squared x. So 10 bracket, I'm going to replace cos squared x with 1 minus sine squared x using Pythagorean identity, and then plus 3 sine x minus 9 equals 0. So let's open it up. Let's do the distributive property. So 10 minus negative 10 sine squared x plus 3 sine x minus 9 equals 0. So I'm going to collect the like terms. So 10 minus 9 is, so it's going to be negative sine squared x plus 3 sine x plus 1 equals 0. Okay, now again, this looks like what we just did before. It looks like a trinomial, and because it starts with negative for the highest, with the coefficient for the higher degree, I'm going to switch signs. So move everything to one side. So it's going to be 10 sine squared x. Now it's going to be negative 3 sine x minus 1 equals 0. So if I have to say let sine x equals a, this technically looks like 10a squared minus 3a minus 1 equals 0. So if you can factor it, it's going to be using product and sum and decomposition. It's going to look like 5a plus 1 and then 2a minus 1 equals 0. So let's replace a with sine. So it's going to be 5 sine x plus 1 and then 2 sine x minus 1 equals 0. Okay, so we're almost done. Now what we can do is we can let each factor equal 0 because it's something times something. So we can say 5 sine x plus 1 is equal to 0. So that means sine x is going to be negative 1 over 5. Therefore, so if I were to do the inverse of sine, x is equal to x inverse of negative 1 over 5. So punch that in your calculator and you will get 0.2014. Now sometimes you may not get the radian. Okay, so if you get a decimal, that's totally fine. Then we will work with that. So then, using your cast rule, we have to figure out, so this is my related acute. So which quadrant would my sine be negative? So sine is going to be negative in quadrant 3 and quadrant 4. So let's see. So for quadrant 3, it's going to be pi plus related acute, which is 0.2014. So you can do 3.14 plus 0.2014, and that will give me 3.343. Okay, And then for quadrant 4, you're going to do, because it's going to be 360, so 2 pi minus theta, which is my related acute, 0.2014. And that's going to give me 6.082. Okay, so these are my two answers for the first factor. Now let's take a look at the second factor. The second factor is 2 sine x minus 1 equals 0. So therefore, I'm going to move 1 to the other side and divide it by 2. So it's going to be sine x is equal to 1 over 2. And then if I were to do the inverse of x, then you will get pi over 6, which is 30 degrees. So then we found my related acute, which is pi over 6. And now we are going to do the CAST rule, C-A-S-T. Now let's ask ourselves, which quadrant was my sign going to be positive? So sign is going to be positive in quadrant 2 and quadrant 1. So we know that in quadrant 1, we already know it's going to be pi over 6. Quadrant 1 is equal to, x is equal to pi over 6. And then for quadrant 2, the formula is pi minus pi over 6, my related acute. So that means I'm going to get, so common denominator, 5 pi over 6. Okay, and there you have it. So we have two answers. So in total, we have 4 answers that will give me the angle when you're solved for this equation.